In exercise 4, what we're going to be doing is creating a link parser. So what this means is that you're going to write a package that accepts HTML in some format. I'm going to be doing it as an io.reader, but if you did it as a string or something like that, that's fine. It's kind of, up in the air as to what you think is best. We will be using this later in one of the other upcoming exercises to build like a sitemap builder. And as a result, it'll be easier if this is a reader. But you can make whatever work, and you could always grab my source code once you get to that exercise, once you've completed it. So what we're doing here is we're trying to convert some HTML documents into something that we can sort of use inside of our Go code. So we're taking something like this link right here that I have highlighted, and we're going to try to convert that into a structure sort of like this. So we're going to try to pull the link, which is the href tag, or the href attribute inside the tag, and we're going to put that here, and then we're going to try to pull all the text from the elements inside of that link, and we're going to put it into the text thing. We're going to kind of ignore all the HTML and that sort of thing. We're just going to try to get rid of all that. The idea here is that we just want the text and what that text links to. Now, the text won't be as important for upcoming things, but where you might use it is if you were doing something like building a search engine and you wanted to know which key terms are used to sort of link to things. You might use that text in that sense and not care as much about the HTML. In our case, we're just sort of doing it so you get a little more practice parsing these HTML documents and seeing how to use the net.html package. So what I'm gonna go over some notes real quick. The big thing here is that you just want to get something up and running first. Well, let me just start at the first note. I'm going to recommend using the net.html package. This package is provided by the Go team. I'm going to scroll to the top here. It's provided by the Go team. That's why it's under golang.org/x. Everything under that /x is provided by the Go team. It's just not under the same guarantees as the Go standard library, and it doesn't come shipped with the Go standard library because it can change on different schedules. It doesn't have the same backwards compatibility guarantee, things like that. These are all still very stable, good, reliable packages. They're just done this way so that they have a little more flexibility for these types of things because maybe standards are changing and things like that. These are the type of packages that can't go on the same release schedule as the Go language itself because they just might need change differently. And sometimes some of these do get pushed into the language. I think the context package is the most recent one, where it started off as a /x thing and then it eventually got merged into the standard library. So don't try to do, I'm just going to say this up front, don't try to do this tokenizer stuff. It's sort of shown here at the start. I don't think that's what you're going to want. I think what you're going to want is this parse down here, which will return some HTML nodes. And then you can use those nodes to try to go through the document and sort of see what each thing is. I haven't used this package a ton, so I can't say for certain exactly what you want, but I know it'll do what we need to do. I just don't know the specifics of it until we sort of jump into it. So you're going to see me learning it while we're going through this. The next note, you can ignore nested links. So if you've got a link like this and then you've got another link inside of it, you can ignore that. I don't even think this is valid HTML. I'm not really sure how a browser would render it or what it's supposed to be. So just don't worry about things like that. If you get the text here, great. Don't worry about getting two different links out of it. All right, third note, make sure you just get something working before you move on to trying to fix it, make it perfect. There's a lot of weird edge cases, especially when it comes to HTML documents, and if you're taking real world ones, it's even worse because people might not have completely correct HTML. They might have links inside of links, they might have comments inside of their links that you accidentally parse as text. There's all sorts of weird edge cases that you can think of that might be there. But just get something working first, and then go try to fix the bugs and try to fix the edge cases and try to look at those things. I have provided a few examples to try to help with that. I think there's 4 right now. If you scroll to the top here, yeah, there's 4. And then the last thing is the 4th example is intended to try to help you with the comments inside of inside of a link. And I have that there because this is a corner case that I think is probably going to be the most common one people miss. But it'll sort of show you, the example will give you one that you can test against to see if you're getting the text inside of the comment, because you don't want to be getting that text. That's not something that's going to be rendered on the page, so you probably don't want to render it with your stuff. And there are node type constants inside of the net.html package that I have linked here. These will kind of make it a little bit easier for you to figure out, which type of node you're dealing with and whether or not you want the text from it or not whenever you're trying to pull the text for a link. Okay, I think that's everything here. If you want some bonus exercises, really it's just trying to improve your test cases. So, maybe grab a couple extra HTML files and try to run your code against it and see how it does. I don't have anything to sort of make this tricky or harder. I want you just to sort of, look at edge cases and try to make it work as best you can. This exercise, just a heads up, is going to vary kind of based on what your experience level is like. If you are a computer science student and you understand graph theory and trees and DFSs, this exercise will probably be a little bit easier. But if you've never dealt with those things, it's not that you can't do the exercise, it's just that it might be a little bit trickier, and some of the stuff we talk about might be a little bit hard to sort of, grok right away. So what I would suggest is to go read a little bit about graph theory if you do get stuck. Learn about trees, breadth first searches, and depth first searches. Those are pretty much all you have to really learn about. And you don't have to. I'm not trying to say you have to. I'm just sort of saying if you do get stuck, it's a good place to start as to learning a little bit more about what's going on. But before you do that, what I do want to show you is that HTML files are really just trees, and that's why this sort of thing matters. So looking at this example 2, we're going to look at this body section here, and what I want you to see is that when you're looking at it, really this is a tree where body is the root node, and then this heading here is a single node or leaf underneath that tree, and then likewise this div is another leaf underneath that tree, and it has its own set of children, this A tag here and this A tag here. So if we wanted to visualize it, it could end up looking something like this, where we've got the top of our tree is this body node, and then we've got this left node here is this H1 tag, and then we've got a second node here, which is this div, and it's got its own set of children, and that's roughly what the tree ends up looking like. Now they can get much more complicated if you're looking at a really big HTML file, but they will always, proper HTML will always be a tree like this. It'll always have a bunch of elements that sort of contain other elements, and it sort of gives you this tree structure. So that's important to know because the HTML package is going to be returning things called nodes. Well, these nodes are really just one of these squares inside of an HTML file. Now it might have text in it, so it might be a text node. Let's look at this. This part here, this check me out on Twitter, that might be a text node that it gets that just has that content. And then this right here might be a second node underneath that A tag that is an I tag. And then, it's not shown here on this graph, but they would both be underneath of it. So it's important to understand that it's going to give you a bunch of different nodes, and this is sort of how you traverse through the tree. So when you're looking at these different things like parent, first child, last child, previous sibling, and next sibling, they're pointing to different parts of the tree based on where the current node is. So if we're looking at this div right here, its parent is going to be the body tag. Its first child is this left A tag. Its last child is this right A tag. And if it had another child, it would be that one. So, it's whatever last child it is, the rightmost child based on the way we set up this graph. Its previous sibling is going to be this H1 because the H1 is also a sibling of the same parent. So they're both siblings of body. And it's the one that came before it inside of the HTML document. Now, if you call its next sibling, well, nothing came after this div in the HTML document, so it's going to be nil. But if you were on the H1, for instance, and you called next sibling, it's going to be this div here. So I know that's a lot, it seems like a lot to take in, but just keep it in mind as we go through here and, start to actually define our API and start writing this code, because, it's nice to just sort of understand that this is a tree, and we will be using some of these algorithms that you hear a lot of people say you never actually use whenever you're coding. Well, the truth is you do every once in a while. So it is kind of handy to have a rough idea of how they work. To start, where I like to start is basically defining the API. So by that I mean thinking about how an end user would like to use what you're building and how you could make that ideal for them. Think about like what functions they would like to call, what those are going to look like, and how they can be the best experience for that user. I think this is important because a lot of people don't think about it that way, and instead think, all right, I'm going to write this the easiest way for me. And the downside to that is that most of the time when you write a tool like this or a package like this, it's going to be used maybe by 100 developers many, many times, and you're going to write it once. So to push that work onto them, the 100 different times they use it, is really a bad design. It's something where they're all going to have to make these hard decisions where you could be making some of them for them. Now, that isn't to say that you should never give people options and that sort of stuff, but there are a lot of cases where I see packages that could have been designed better had they thought about, all right, what was the ideal use case first. So to do this, we're going to open up parse.go, which is where we're just going to put all our code in. And this is going to be package link. And the first thing we're going to want to ahead and define is the link type. So type link struct. And this is the type that we're returning a single link in. And we know that it's going to have an href, which is a string, and some text, which is a string. And these are both things that we sort of looked at the exercise explanation. We want to return something like this that just sort of is a simplified version of a link. So we're going to go ahead and say link represents a link in an HTML document. Let's go ahead and do this. In an HTML document. Let's put that on the new line. All right, so simple enough. We probably could go into more detail here, but I think this is fine. And the next thing we want to do is think about how would we like to use this? Well, in my mind, what I'd love to do is have a reader. And this is like my HTML document. And I'd love to be able to say something like, give me the links or any errors in link.parse of R. Something like this. That would be the easiest way to do this. Not have to call anything else extra, not have to do any other setup, and not even having to turn this, maybe I have a reader, I don't want to have to turn it into a string or something like that. And the reason I don't want to have to do that is there's all sorts of cases where you're going to have a reader. So if I open up a file in the local file system, or if I do a web request to another web server and I want to parse that HTML, these are all cases where I'm going to get a reader back. So I think a reader makes the most sense here because it's what they're most likely going to be working with. So to do that, we can just go ahead and say func parse, which takes an io.reader, and it's going to return either a slice of links or an error. And then we can document this. We can say parse will take in an HTML document and will return a slice of links parsed from it. I don't know if I could type today. All right, and then here we're just going to say return nil, nil. That's good enough, I think, for now. We'll go ahead and we'll fill this out in a bit. But before I fill it out any further, what I like to do then is to go ahead and just write some code that uses it. Now, this could be a test. It could be, just an example program. It's really what makes the most sense to you. In this case, I'm just going to go ahead and make an example program because I don't want to dive into testing and sort of cover all the details there. So I'm going to do make dir examples. And I'm going to atom examples. Actually, let's go ahead and say ex1. And then we'll atom examples, ex1, main.go. So we're going to go ahead and define this main package. And I'm going to go ahead and var HTML equals, actually I don't, it's probably fine if I use HTML, but we'll do example HTML equals, and we're just going to paste in everything from ex1.html. Now, technically we could open up that file. We've done that several times in the past with other exercises, but the reason I'm not going to be opening up a file here is that I want to show you how to create a reader out of a string, which is something we haven't done yet. So I'm going to say r : equals strings.newReader, and we pass in example HTML, and that gives us our reader. Then we're going to do links, error : equals link.parse, pass in r. If error is not equal to nil, we want to panic. Otherwise, let's print f. Let's do %+v so that we get a lot more details out of all the links. And then we'll pass in the links. So that went ahead and imported the fumped, the strings, and the link package that we're creating. And that's it for creating a reader out of a string. I know it's simple. It's just strings.newReader, but it's something that I see a lot of people, especially when they're getting started with Go. They'll have a string, and they'll be wanting to use a function that needs a reader, and they'll say, "How do I do this?" I just want you to show that it is really easy to do. So you just call strings.newReader. All right. So now that we have that, we can go run examples ex1 main.go. And you'll see here that it just spits out an empty slice because we're not getting anything back when we call parse. It's just returning no right now. Now that we've defined sort of what our API is going to have, it's time to start actually implementing this. And I just want to give you a little warning ahead of time. This is the first exercise that I think we're jumping into where it's going to be a lot of not just sort of messing around with Go, but sort of seeing concepts in programming that you might not be familiar with. I mean, I mentioned it earlier, we're going to be using trees and recursive functions and that sort of thing, but it's just knowing all of that, it's going to be a little bit fuzzy if you aren't familiar with those things. That isn't to say that you can't follow along and you won't learn from it, but don't get discouraged if that is the case in this video. A lot of the other exercises we'll be doing won't be this involved, but I just really wanted to get you something that wasn't just a cookie cutter, all right, print hello world. I wanted to do more exercises that required a little bit more thought and thinking about what you're doing and seeing what's going on. So what we're going to be doing here is we're going to be, well, first we need to go get the package we're going to be using. So it's golang.org/x/net/html. I'm going to go ahead and grab this HTML package we're using. So now that it's installed, our next step is going to be to use it to try to parse this reader that we have and to get HTML nodes from it. Well, before that's really going to make a lot of sense, you need to understand how these types work with the nodes. And I'm just going to quickly go over them. We've got text node. This is a section of your HTML that is just text. So looking here, a link to another page, that's text. So it's going to be inside of a text node. The next thing we have is a document node. This is kind of just a parent wrapper node. Your root node is going to be a document node. So no matter what, when you parse an entire HTML file, it'll add this document node at the very top. So if we're looking at this, you would think HTML is going to be your first node. It's not. The top of the tree is going to be a document node. And it's going to have a child, which is an HTML node. It's an HTML, it's actually an element node as the type, but it will be that HTML node. So document node is just sort of like the parent root node. I don't know if it has other purposes within the net HTML package. I haven't dug too much, but based on what I've seen, that's definitely something that it serves the purpose of. After that, we have element node. Element node is basically an HTML tag. So an H1, a div, an A link, or an A tag, a body tag. Any of these things that are inside of these brackets are probably going to be an element node. Or I think they all are. So next is a comment node. This is going to be something like, not that example, like this. It's an HTML comment. So you can still access them once the the HTML file is parsed, but there'll be something separate so you can sort of try to distinguish them from the rest. Doc type node, I think, is just something like this type of element, but I'm not really sure. I haven't dug too much into it. I haven't even written this exercise, so I can't tell you for sure, if that's what it is or not, because I'm doing it as I record it. Okay, knowing that those are the node types, it's useful to know that when you're looking at each node, you can look at the node type, like they're doing here in this first example with parse, and you can decide if it's an element node. That means you can check to see if the data, see if it's an A tag, see if it's something else. So that's what's going on here. We're trying to see, is this an A tag? And then you can do something with it once you know it's an A tag. Otherwise, some other things you can do is you can look at the children of a node and sort of iterate over them and call recursive functions in order to do things like a DFS. So that's what we're going to be doing. So the first thing we're going to write is a way to take in a document. We're going to parse it into an HTML node, which is going to be the root document node, and then we're going to write a DFS that will go over every single element inside of it, and we're just going to go ahead and just print them out. With we're going to print some spaces in front of them, but that's fine. So what I'm going to go ahead and do is do doc, error, equals html.parse r. If the error is not equal to nil, return nil, error. Otherwise, we're going to, let's just call this demo of doc, or recur of doc. We can just call it DFS even, that's fine. So we'll just call it DFS. We're not going to return anything with DFS just yet. We'll go ahead and fix that up in a bit, but I just want to show you, when we want to look over the entire HTML document, it's good to get an idea of how to do that. So first we'll do func DFS, which takes in a node, which is an html.node. And it doesn't return anything. It just does something with that node. So what we're going to do here is we're going to say if n, actually, let's just go ahead and let's add something special here. Let's add a variadic, or let's add a second argument, which is going to be padding. It's going to be a string. So we're going to have no padding for the very first thing we pass in. And we're going to go ahead and say format.println padding, comma, n.data. Data is going to be sort of what's inside of the node, so we're going to be printing out everything that way. So once we print out the node that we're on, we're going to go ahead and then we're going to call all of its children, doing something like they have here. So we can even copy that code, paste it here. We're going to look at all of its children, and we're going to call the same DFS, except we're going to add a little bit of padding. So for all of its children, we're going to want to indent them a little bit, sort of like you would with an HTML file. So what we'll do here is we'll say that C is equal to n's first child. That's what we want. As long as C is not nil, we continue running this loop. And then the third thing is every time the loop ends, we want C to be assigned to its next sibling. So here we'll do DFS of C, and then we'll do padding plus 2 extra spaces. So that way, if we keep on recurring many times down, this padding will keep getting bigger and bigger, as we go down that tree. So looking at this, so at body, maybe the padding is just 2 spaces. Well, here we're going to add 2 more spaces, so it's 4, and here we'll add 2 more, so it's 6. So you'll get to see that padding sort of indenting based on how deep we are in this tree. Okay, so let's go ahead and run this. I think that's what we want. And we do have a bunch of empty lines here. There's different types of nodes that maybe we don't want to necessarily deal with, or maybe they're empty string or text nodes. I don't know for sure right now. But what's important here is you're seeing that our HTML file as we defined it is roughly what we're seeing here. And you could even do something like if, let's say, message is equal to n.data, if n.type is equal to html.element node, then we're going to say message is equal to this plus message plus this. So we're going to go ahead and show it as a tag. And then here we can just replace this with message. And if we run the same thing, you'll see that we're now printing out these tags, and then these are the text nodes. So really cool to see this. I think I added this second link. Yeah, in case you're wondering where that came from. I added a second link here, just to sort of make it a little bit easier to verify that we're getting 2 links correctly. But you don't have to do that your first run through. But that's what's going on here. We're just sort of recurring through the whole tree, and you're seeing that we're doing stuff. Okay, so now that we have our DFS working, what we want to do next is sort of change this a bit so that as we're going through the DFS and we're looking at all the different nodes in this HTML document, as soon as we run into a link, we want to somehow note that we have a link and save it. We want to somehow return that link so that our parse function can then use that to sort of build these links that we have up here. So the main idea in my mind is we're going to do something like our DFS, but it's going to be step 1, find nodes and find link nodes, nodes in doc. Step 2 is going to for each link node, 2.a, we'll say this will be build a link. And that might involve, this is a bad description. We're going to be building these links for each one of those link nodes. And that might involve, getting the href from it, which is, we're going to have to know some way to get the href tag out of a link node. Then the second thing is we're going to have to get the text out of it. So once we've done that and we've gotten the text and the href out of each one of these link nodes, then we're going to go ahead and 3, return the links. So that's roughly the 3 steps we want to do. But the first step is to find all these A tags, the nodes that are link tags, with our DFS. So we're going to go ahead and update our DFS to do that. So instead of just printing everything out, it's going to actually specifically look for certain link nodes, and it's going to return them. So let's go ahead and rename this. Actually, we can just write a new function. We'll call it link nodes, and it's going to take in a root, which is an HTML node, and it's going to return all of the HTML.nodes that are links. So that's what we're doing here. Well, we know that we need to return some HTML nodes, so let's go ahead and say var ret is going to be our HTML node slice, and we're going to return it once we're done with this whole function. So we've gone ahead and just defined the return variable we're going to work with. The next thing we want to sort of think about is what is the base case. So in what situations can our function just return whatever it has? And that's the case where if we pass in a link node, then we know that our function doesn't need to do any more work. It's that's a link node. There's nothing else to do. So what we can do is say if n.type is equal to html.element node. So this is if it's an element node, which means that it's a tag of some sort. And if n's data is equal to a, so it's an a tag, then we're going to return an html.node, and the only thing inside of this slice is going to be n, the element that was passed in. So that is our base case. Anytime this happens, we just return that slice. Otherwise, we need to go look at all the children of the current node because it's not a link. It might have some links underneath of it, but we don't know that yet. So what we're going to do here is we're going to say for c : equals n.firstChild, c is not equal to nil, and c equals c.next sibling. And this will allow us to look over, all the siblings for whatever node is passed in. And we're going to say that we want to make ret equal to, sorry, give me 1 second. You done, bud? Yep. All right. He was scratching his neck with his collar. All right. So now that we're going to go ahead and append. So here we want to append whatever link nodes are found for each child to our return variable, and then we're going to return it. So it's going to be append ret, and then we're going to call link nodes, pass in c, and then we have to do ... here because link nodes returns a slice, which you can see here. And what we really want are HTML node, individual nodes, to append to this. So the ... will sort of expand this for the variadic parameter. Because append is really a function that's something like, well, it's not exactly like this, but it'd be something like append slice, and then it's ... for whatever args or vowels or whatever, something like that. So we want to go ahead and be able to expand this so it matches the second part. And if you aren't familiar with that, variadic parameters are something they're relatively similar in most languages in my experience. So it's not something like brand new to Go or anything like that. It's just that's just how variadic parameters tend to work. So that's everything we need for this link nodes function. It will return all of the link nodes that are within a document. So let's go ahead and update our code up here and say nodes : equals link nodes for the doc. And then we're going to say for each node in the nodes. Let's just print it out for now, just so we can see what we're getting and go from there. This needs to have range, so we want to do range over all the nodes, not just for the nodes. All right, so we can actually delete this DFS. We're not using it. And I just want to save this and run it and verify that everything is working as expected. So you'll see here that when we run this, it actually prints out 2 links. So it looks like these are the links that we're expecting. It's got the href of what we're expecting there. And I've tweaked this even more. I keep changing it as I'm sort of off screen to make sure things are right. But we've got these 2 links. That's all it is still. It's just the first link and the second link. What we want to do now is we want to go ahead and build links using these nodes. So we want to build these links using these HTML nodes we have that we know are A tags. So the first thing we're going to do is, well, let's just do this as a function. We'll say build link. It's going to take in an HTML.node, and it's going to return a link. Well, we'll say var ret is going to be a link, and we'll return ret. And then what we're going to do inside of this is we're going to say, we want to get the attribute, so that href attribute. If you look here, this thing here that points to this page 2 value, we want to get that out of our links so that we can, or out of our HTML nodes so we can put them in the link. Well, the way you access these with HTML nodes is to do something like for attributes in the range of all of the nodes attributes. So we can't look at a specific one because if you look at n.adder, this is actually a slice of HTML attributes. Well, that means that there's no keys to look things up by. It's just a slice. So we need to iterate over the entire slice. And for any attribute inside of this slice of attributes, if the key of that attribute is equal to href, then we know it's the href attribute that we want to get the value from. And we're going to say ret.href is equal to the attribute's value. And when this happens, we can also break out of our for loop, so we'll add that break there. And that's just a minor optimization. You don't really have to do it, but it's nice to have. All right, so this will get us our links. The next thing we're going to want is the text. So we're just going to, for now, say ret.text equals to do parse the text. And we're going to return ret. And we're doing this so that we can come back up here, and we're actually going to go ahead and build our links and return them so that, with the rest of our code, we can actually see what's going on. So we're going to say var links is going to be a slice of links. And then here we're going to say links equals append links, and we're going to pass in build link with each node. And then finally, we're going to return those links. So now when we run this, you'll see that our href is getting set for each link that we build. The only thing that's really left to do is to figure out this text part. How do we parse the text and stick it in there? Well, the first thing we're going to want to do is, is just write a function to do, not the first. We're going to write a function to do this. The reason we need to do this is because I know that the text is going to be something where we need to do another DFS. So if we're looking at like this link here, you'll see that if we were to organize this in a little bit better format, first we've got some text, then we've got a span, and then we've got the end of the A link. So if you look at this, it's really two nodes are going to be inside of it. We're going to have this node, and then we're going to have this sum span node. And we want to get the text inside of this sum span node and pull it out so it's included. We don't just want a link to another page. We want a link to another page space sum space span. So we want all of that text. So knowing that, we're going to go ahead and say func text. It's going to take in an html.node. And this is going to return a string that represents all of the text inside of a specific node. And it's going to try to ignore comments and stuff as well. I think the way we're writing it will, at least, and we'll find that out when we try the fourth example. So first I'm going to say if the type is equal to html.text node. So this is our base case. We're saying that if whatever node we're looking at is a text node, well, we don't want to look at its children because it's a text node. It's probably not going to have children. We just want to return the data for that node. All right, so otherwise, if the type is not equal to html.element node. So what we're saying here is if the node we were given is, say it's a comment node, or say it's a doc type node or something like that, we don't really care about those. It's not something we're going to be doing a lot of work with. We shouldn't be getting them, for the text function call, because this is only intended to work for A tags. So, when we get here, if it's not an element node, we can assume that we probably don't care about what the content is. So for here, we're going to return the empty string. And that's our two base cases. So from here, we're going to go ahead and do our DFS, where we're going to say var ret as a string. And this is just going to be an empty string. And we're going to say for c is equal to n's first child, c is not equal to nil, and c equals c dot next sibling. So the exact same for loop we wrote before is going to be written here. The same for loop is here. And what we're going to do is we're going to say ret equals or plus equals text of c. So for every single child, we're going to get the text of that child, and we're going to go ahead and add it to ret. And we can go ahead and add it with a space here in between each and every one, because maybe each child has a separate, some sort of div or something like that separates them. So we'll add the space here as well. Now, I will say that building strings this way isn't the most optimal way to build strings. That's fine. I think this is going to be fine for what we're doing, but you could look into things like a byte buffer or something like that to build the string in a more optimized way. I think I even write about this a little bit on my blog in one post. So, there are other ways to sort of do this, but I'm doing this for now because it's simple. Then finally, we want to return ret. And eventually we're going to look at a bug, not a bug, but like some ways we can clean this up. But for now, I'm just going to leave this be. All right, so let's go ahead and run this. And we don't call this text function, so that's not going to work. Let's call text of n. Now let's run it. And you'll see here that what I mentioned earlier, our text here has a bunch of new lines and spaces and things like that in it, and that's probably not what we want. We're not really... It doesn't make sense to keep that because in HTML, a bunch of spaces back-to-back or new lines, they don't get rendered that way. They just get rendered as a single space. So knowing that, it probably makes sense to go ahead and take all these spaces and just trim them all up and just replace them with a single space. Well, the easiest way to do that is this fields function in the strings package. What it does is it splits a string around any instance of one or more consecutive whitespace characters. So if you've got new line characters, anything that's defined by unicode.isSpace is what it says here. It'll go ahead and split it. And you can see here when you run it, this string with a bunch of spaces, then foo, then bar, then baz, and some spaces, gets split into a slice like this, where each part that's not a string is its own element inside the slice, but it's just a big slice of them. So where this is useful is we can also use the join function inside the strings package, which then takes a slice of strings and you can join them with a single separator in between each one. So in our case, we're going to join them all with a single space. So by using these two in conjunction, we can separate or take our entire string, get rid of all the extra white space, and then merge all those individual pieces together with single spaces. So in code, what this looks like is return strings.join, and then we need to pass a slice. So we're going to call strings.field or fields for ret. So strings.fields is going to create that slice for us, where every individual part of the string is split based on white space, and then we're going to join them together with a space separator. And I think that imported the strings package up here, which is why it went down in line. So let's go ahead and run this. And you'll see that our text is much cleaner now. We've got a link to another page, some span, and we've got text, a link to a second page. All right, cool. We've got this working. What I want to do next is I want to go ahead and try it out with some different examples we have. So we're going to go to, say, example 2, copy this all, and maybe it makes sense just to copy this whole thing, maybe to create a folder. So let's do cp examples, let's do ex1, and we'll do examples ex2, 3, and 4. Oh, it's a directory, crap. I didn't want that, but I can rename it. So this is going to be renamed to example 2. All right, so we've got a bunch of these main.gos. Let's go ahead and replace the HTML inside of them with the HTML we wanted. So 2, we'll replace with this. 3, we're going to replace with this, which is pretty big, but that's okay. And for 4, we're going to replace it with this. It's short HTML, but has a comment there, which is good to see how it works. And I'm actually going to start by running example 4. And you'll see here that the text dogcat is there, which is expected, but it doesn't have this comment at the end. So I do want to mention that if we didn't add, where's the text? If we didn't add this part here, say if we were to comment that out, the element node part, and we were to save it and run this, I believe this is the one. Actually, it might not, but I'm not sure. Nope, it doesn't. Okay. So So where that we could actually change that is if we said n.type is equal to html.comment node, return n.data. So depending on how you wrote it, you might have had something that, commented text should not be included. If you weren't checking these, if you were just saying like, if it has no children, just return its data, that's where you might have accidentally ran into this. But because of the way we coded it, we didn't actually run into this, so it's not really a big deal. Let's go ahead and look at example 3 now. Actually, let's go to 2. We'll just do them in order. Example 2 has check me out on Twitter, and the Gophercises is on GitHub. So this whole I tag really shouldn't end up rendering anything. It's a font awesome icon, and in HTML it'll end up showing something, but here in more parsing we don't know that, so it's just going to end up being empty. So you'll see that check me out on Twitter doesn't have that I tag, and this text Gophercises is on GitHub. You'll see that it's a little bit weird because we've got this space, so maybe we want to fix that. Maybe we want to say that if there's not a space here, this doesn't actually make sense. So let's run that, and you'll see that now this actually gets fixed. We've got Gophercises on GitHub, and the spacing isn't really weird. So that was just minor bug we introduced while we were doing this, and we didn't quite realize it. All right, so finally, let's do exercise 3. And lost need help, and we've got something else. So what's this doing? So where are our links? I've got login as the first one. So you can see here we've got the, this goes to basically the same page with the pound sign. But the text is login. It has a font or another font awesome icon, but that doesn't render anything. So that one looks right. I'm looking through here. It looks like we're getting this one correctly. This is a link that's inside of a form, and our code is still parsing that correctly. And then what's the next one we see? This is a Twitter link, and it's going to Marcus Olson. Excuse me, Marcus is the person who designed the gophers that are used on the website. So he designed all the gophers and sent me the source files for them, and then I animated them for the website. So that's why he's listed on the website here as somebody who really helped out a lot with that. And you'll see that, yep, that's what this link should be. Okay, so I think that's everything. This all appears to be working. I'm gonna go ahead and save this. I don't think there's anything else we need to change for the time being. I know this was a lot. I'm just gonna go ahead and just put that out there. I originally put this as exercise 4, and for now it's probably gonna stay there. But after going through it, I kind of realized that maybe it wasn't the best early exercise, but I still want to keep it there. If you are a computer science student, I do think, somebody who's studied a lot of these algorithms, I think it's going to be easier, but it still isn't the easiest exercise. So, don't get worried if you didn't quite get it on your first try. That's okay. Just, try to watch the video and try to make sure you understand what we're doing with everything, and that should really help out.